Hello everyone, this is Kevin Cofield with Cofield Aviation. In this video, we're going to cover weather information part 1. Okay, so we're going to break down the sources of weather. So where can we get that weather? We're going to break down METARs. We're going to break down terminal air forecast, graphical aviation forecast. We're also going to discuss stuff like the MOS and the daily forecast on Foreflight. We're also going to discuss what makes a thunderstorm. Okay, so instability, lifting force, and moisture, and what can give us those. So we're going to talk all things atmospheric stability with high pressure and low pressure. We're going to discuss fronts, so cold fronts and warm fronts and occluded fronts and stationary fronts. And we're also going to talk about moisture when it pertains to the types of clouds and fog and stuff like that. Okay, so we don't have to be meteorologists to become pilots, all right? But we need to have this basic understanding of how the weather works. But more importantly is we need to understand that weather is dynamic and weather is constantly changing. So whether it's the go or no-go decision that we're coming up using all available, weather resources, whether that's, that go or no-go decision where we decide to either go or not go. But even if we decide to go, we don't stop looking at the weather, right? Even, en route, we're constantly looking at the weather, between, Foreflight and ADS-B weather in ATC services. And we're constantly evaluating, how is that weather changing? Is it getting better? Is it getting worse? And always have an out. That is the most important thing as pilots, is to have an out. Okay, so go no-go decision can include okay, well, if the weather's not great here, then I can divert east or west, or I can turn back around. I know the weather's going to be great in that direction. Okay, I know most of us pilots are kind of type A personalities. We're kind of mission oriented, and the fact that I want to get from point A to point B, but you cannot have that thought process as a pilot flying. You've always got to be flexible and ready in any given point in time to divert, to go to an alternate or whatever. So the big thing with weather as a pilot is that it's dynamic, it's constantly changing. But again, we need these resources in this video that we're going to go, and in the weather information part 2 video, where we're going to get into airments and segments and all that's good stuff. But we need to have this information to make the absolute best decisions as possible. So I'm here at the CofieldAviation.com website, and I'm going to go right here to the student section, and I'm going to go to the downloads and documents, and then we're going to go down here to weather information. So these are basically printable PDF files that you can print them off, make notes as you're watching the videos, or just print all these off and create a binder for your oral exam. And more importantly, though, is your continued education and learning after your check ride. So here is weather information. Back up here to the top. So all right, let's get started. All right, so some of the sources of weather data. Okay, so I use Foreflight briefings and the Foreflight imagery, and I do have a Foreflight video that gives you details on kind of how I do the briefing and how I do flight planning through Foreflight. You can see that on the Cofield Aviation YouTube channel. Another is the flight service station, so you can call 1-800-WX-BRIEF. They're trained flight briefers that will give you briefs. You have 3 types of briefs that you can request from the flight service station. Outlook briefing, so that's greater than 6 hours from the time of departure. Standard briefing would be within 6 hours. They're going to give you the whole briefing there. Abbreviated briefing would be a specific request. So like, okay, I only want to get TFRs, or just give me NOTAMs and TFRs, and I'm good, or whatever. 1-800-WXBrief.com. It's just the digital version of the phone version of calling. And then aviationweather.gov. All of these are just different sources that we can get the weather. Okay, so weather information, 91.103 The NWKRAFT goes through the pre-flight action required. You know, we got to have NOTAMs, weather, non-ATC delays, runway lengths, alternates, fuel, and takeoff data. So this is the W. So what we're talking about here is how do we get all available weather information resources for our flight. Okay, so this video is focusing in on the 9103 pre-flight action required, talking about the weather. Now, there is no necessarily legal weather briefing, if you will. Okay, the regs just say we have to be, you know, aware of all, you know, weather along the route of flight and all available resources, all available weather information that we can. So it doesn't say, okay, you have to do Foreflight briefing or you have to go to aviationweather.gov or whatever. It doesn't specify where we get that weather. Now, I will say a caveat to that is, you know, if you're doing a Winter Hunter weather brief, or you call a flight service station, or you're doing a Foreflight briefing, like there is a record of it. So to me, that's the important part of doing the Foreflight briefings, and the reason why I like to do is when I hit briefing, you know, there's a record. You know, my tail number. There's a record that I got that weather. So if there was to be something come up, an accident or some issue, right? You know, the FAA is going to verify in 91103 that you went through all that pre-flight action items and that you did it correctly. So to me, that's the reason why I do these, is because there's a record that I actually checked the weather. But, you know, whatever weather resource you use, just, you know, make sure that you're able to back that up with what you what you looked at. So, all right, this is kind of how I break down as far as what do we use, all right, to get the weather. Now, if we're looking for the weather right now, okay, we're going to use METARs. Now, we're going to break down the three types of METARs, AWOS, ASOS, and ATIS in just a minute. But if we're looking for the weather, again, right now, we're going to pull up a METAR, all right? If we're looking for the weather in the next 24 to 30 hours, all right, then we're going to pull up a TAF, a terminal area forecast. Now, the thing with the TAF, and again, we're going to break each one of these down in detail. That's the whole point of this video. But the whole thing with the TAF is it's only good for a 5 nautical mile area around that station. All right, so I live in Alabama, and so we have only a few TAFs around, like Birmingham. Our home airport is the Gadsden Airport, Kilo Golf Alpha Delta, and it does not have a TAF, all right? So the closest TAF is about 20 nautical miles away. So technically, where we are in Gadsden, we can't use a TAF when we're looking at the weather, because that terminal air forecast is only good for a 5 nautical mile area around the station, okay? So we're going to look at a TAF in detail in just a minute. So if you have an airport that's more than 5 nautical miles away from a TAF, you know, there's not a whole lot of airports out there with terminal air forecast, then what we're using is the Graphical Aviation forecast. Okay, so this is good for a large geographical area, and it's basically, again, it's used when your airport is outside the 5 nautical mile distance from a TAF station, and when your airport does not have a TAF, right? So just like we were talking about. This used to be called the area forecast, and when I started flying 20 years ago, it was the area forecast. Also, we didn't have Foreflight. We didn't have all this awesome internet weather sources 20 years ago, or at least I didn't know about them then. I always call 1-800 weather brief. So that was a thing that I did before every single flight, was call a flight briefer and get to either a standard briefing, outlook briefing, or abbreviated briefing. Now, if we're looking for the weather greater than 7 days in advance, or up to 7 days in advance, we're going to look at Prog charts to do that. So prognostic equals future. So we're going to break each one of these down throughout this video. Now, little caveats down here at the bottom. Pivotalweather.com, absolutely awesome source. Now, this is a non-aviation source for weather. It's kind of getting a little bit into the weeds, but you know, pivotalweather.com is absolutely awesome. I've made a couple of videos on how to use that, but you know, basically it's like a future radar to me. All right, and it's also a future what are the winds and what are the cloud heights going to be. And you know, I can look 6, 7 days in advance. We don't really have that availability with any of the weather products to determine, okay, what's my winds going to be, what's my cloud height going to be, and where's the weather going to be. Now, obviously, it's all model data, so it can change, especially if you're more than 5 days in advance. It's not all that accurate, right? But pivotalweather.com is awesome in the fact that it's showing you the radar. Like if I've got a flight 3 days from now, I can pull up pivotalweather.com. I can scroll down to the exact Zulu time and day 3 days from now, and it's going to show me a weather radar picture, basically. So it's basically like future radar. Okay, so really good stuff. Again, look at the videos that I have on the website for Pivotal, on the YouTube channel for pivotalweather.com. It's good stuff. Okay. And again, I've got a little caveat. It's not something you need to know for your check ride. All right. This is not aviation content, but it's absolutely awesome for practical everyday use. And then last here is, if you're a Foreflight fan, you know about model output statistics at MOS in the daily forecast. So you're going to see that on Foreflight. This is a nice tool. All right. But one thing you need to know is these forecasts are strictly model data. Okay, so there's no meteorologist that is giving you the MOS or the daily forecast. It's just 100% strictly model data. So, when I'm looking at the weather, okay, I'm going to basically look now for the future here. I'm basically going to look at the nearest TAF. All right, so if it's within 24 hours, I'm just going to look at the nearest TAF. Even if I'm more than 5 nautical miles away, all right, well, if the TAF is showing the weather 15, 20 nautical miles away is going to be X, then it's likely going to be very similar where you are 20 nautical miles away. So I'm going to use the TAF, you use the Graphical Aviation forecast. I'm also going to use the MOS, and I'm going to use the daily, okay, with the understanding that the MOS and daily, there's not a meteorologist putting that together. TAF, a GAF, meteorologists are putting those together, okay? So if I'm going to lean towards trusting one more than the other, it's going to be these two. However, it's part of the picture, okay? So I'm looking at those 4 things: a TAF, a GAF, model output statistics, and the daily forecast. And my guess is the weather's going to be somewhere in between that, all right? So in this W with the weather, that's kind of what I'm doing in the 91103 NWKRAFT stuff when I'm looking at weather. I'm going through those 4 resources, and again, the weather's going to be somewhere there in the middle. So let's go ahead and break down. If we're looking for the weather right now, what are we using? And we are using a METAR. Okay, so METAR shows surface observations. It's issued every hour, depending upon which one here. All right, it's non-scheduled METARs, a specie, are issued when there's a major change in one or more reported elements. I'm going to get to that just a minute when we talk about ASOS. So here are the 3 types of METARs. All right, so we have one is an ATIS. Now, an ATIS is found at tower airports. Human monitors the system. It's issued every hour unless there's a major change to the weather, and that's where you would get this specie. Now, major change, good or bad. All right, it doesn't have to be a bad change. It can be a good change. But the ATIS are issued every hour, and it also includes NOTAMs and additional information about the airport. So if you're going into a class Bravo, if you're going into a class Charlie, you're going into a lot of the class Deltas. Some of the class Deltas don't have ATISes, but majority of the class Deltas have ATISes. So it's literally just every hour a human in the tower that is giving you information. They're telling you the surface observations, winds, cloud heights, altimeter settings. They're giving you runway use, say runway this and this is in use, NOTAMs, any pertinent information, right? And then when you're checking in with the class Charlie or class Delta or class Bravo, then you are saying, I have information alpha, which means that they know you listen to the ATIS and that you know all of that information that they spelled out there. Okay, so that's an ATIS. Now, an ASOS is an automated surface observation system. Now, the ASOS is controlled by the National Weather Service. All right, it is also issued every hour. unless special conditions exist. That little speci again. Same exact thing. If weather's good or bad, then they will do a special observation for the ASOS. They're normally at control fields, all right, and they're used to create the ATIS. So this is literally just the actual, winds and temperature, dew point, and altimeter setting, cloud height, and so forth. Okay, so the ASOS is more, it's a sophisticated, okay, a lot more sophisticated than the AWOS. So what I want you to remember for an ASOS is it's controlled by the National Weather Service. So it has absolutely everything the National Weather Service needs in order to make, forecasts and so forth. Okay, so it's kind of like the greatest of the METARs. All right, and if you can kind of put it in that perspective. All right, so there's not a whole lot of ASOSs out there. Because I'm sure it costs more money than the AWOS that we're going to talk about. But again, National Weather Service, ASOS, it gives you the most information. So it can tell between freezing rain and freezing pellets and freezing drizzle, and like it has the most sophisticated equipment, if you will. Okay, and again, it is operated by the National Weather Service. Okay, so the ASOS is the best of the METARs. All right, issued hourly, operated by the National Weather Service. It's going to have the greatest sophisticated equipment, so it can tell, like I said, it can tell all sorts of different things because the National Weather Service needs that, right? And again, updated every single hour. Unless a special condition exists, good or bad, then a special observation will be issued. Okay, the last METAR here is an AWOS, and this is the one that you're going to get, you're going to be using most of the time because it's the more prevalent one. All right, the AWOS is FAA controlled. All right, now it's called the 1 minute weather in the AIM, so it's issued every single minute. All right, and it's normally found at the uncontrolled airports, and again, it's called the 1 minute weather. So if you look at the AIM, that's what the AWOS. So what's an AWOS? The reason why we have an AWOS is only for us pilots. An ASOS is National Weather Service, so it's for making forecasts. It's for everybody basically, right? So but the AWOS is literally just there for us pilots to know, okay, what the winds are, what's the cloud heights, what's the temperature, what's the dew point. However, unlike an ASOS, ASOS has a standard, right? Every ASOS will give you all this information. AWOS is not the case, and AWOS is all over the board. You're going to see AO1, AO2, all these different remarks at the end of an AWOS, and it's basically, some AWOSs will only give you like winds and altimeter settings. Some AWOSs will give you just about everything. An ASOS will give you, it can tell between freezing rain and freezing drizzle and ice pellets and blah, blah, blah. Some AWOSs can't, all right? So there's no standard to an AWOS. That's the reason why you'll see all of these remarks. We're going to talk about them here, like all AO2 and all these remarks that you don't really need to understand what all that is. That's just telling you what it can and can't do for the most part. Okay, so remember, AWOS is FAA controlled. The only reason why an AWOS is there is for us pilots. All right, so it's used to give us winds and cloud heights and temperature and altimeter settings and so forth. Okay, but just understand AWOS is FAA controlled. There's no really standard to it. ASOS is controlled by the National Weather Service. It is a standard. ASOS is updated every hour. ATIS is updated hour. Usually at towered fields, there's going to be an ASOS. So those guys that are doing the ATIS, because it's a human, are using that ASOS to give you that weather information plus runway NOTAMs and so forth. So ATIS issued every hour unless there's a major change, good or bad, then you get a speci. ASOS issued every hour by the National Weather Service. ASOS is the better one, right? It's the standard. AWOS is FAA controlled. There's no standard. It can be all over the board, but it's 1 minute weather. So it's issued every single minute. All right, again, some of these remark sections. AO2, automated station that can tell between rain and snow. AO1, it cannot tell rain from snow. So you can see, there's no standard here, okay? This P 0002 would be 0.02 inches of liquid has fallen from the sky. Okay, that's not really all that important. Here would be accurate, dead on accurate temps here. So 25 degrees, dew point would be 22.2 degrees. So, see there, the T would be the temperature is 025, and then this would be your dew point. And that's just more specific, accurate. It's not really all that important. So really, in a METAR, I'm going to teach you how to read these METARs. You need to be able to read METARs and TAFs raw data, okay, for your check ride. I know it doesn't make sense. We live in, it's 2024 now, and I'm making this video. Like, why are we having to do this? Now, my good friend JP Dice, he was a chief meteorologist, pilot, great guy. He makes a videos, a YouTube channel, Beyond the Briefing, and he explains kind of why they had to do this. And it all was basically computers back in the day. The computers did not have the capacity that they do today, right? So they had to write these codes so that the computer's not overwhelmed, all right? And so in 2024, we still have to be able to read these codes. Now, if you go to Foreflight or whatever, then it can break it down, and I will show you that. But okay, so let's read this raw data. So first is going to be the station. So Kilo Golf Alpha Delta, that's where the METAR is. Okay, this first number right here is the day of the month. So this is on the 24th day of the month. So this observation was the 24th day of the month at 0056 Zulu. So make sure you know how to convert to Zulu time. So you go military time, and dependent upon if you're on standard time. So standard time would be for Alabama. Standard time would be military time plus 6. If you're on daylight savings time, which is the majority of the year, right? Daylight savings time would be military time plus 5 to get Zulu time. So make sure you're able to convert to Zulu, because everything in aviation is Zulu. This is automated weather observation. Here's the winds. So if you see, it's calm. So 0, These first 3 is the direction. So if it was like 240 and then you had 10, so that'd be 240 at 10. But basically, here's your direction. There's your velocity, and it's in knots. 10 statute miles. This would be rain. RA would be rain. The little minus sign is light. When we get done with this, there is a legend, okay? So you don't have to memorize all these things. Just go to the legend, if an examiner points, and what does that mean? What does BR mean? All right, baby rain, but mist. Just go to the legend. It's fine. It's fine. You'll learn to get these, but if you see something that you don't understand, then go to the legend. Overcast 011. Okay, so that's 1,100 feet. Just add 2 zeros. And then this would be your temperature. This would be your dew point. So temperature 17, dew point 17. What does it mean when temperature and dew point are the same? All right, we'll talk about that in moisture and clouds. Altimeter 3011. Okay, so this is the meat of the METAR right here. Here's your winds. Here is your visibility, precipitation, cloud height, temperature, dew point, altimeter. The rest of it's the remarks. There's that AO2 we talked about. There's the pressure. There's the precipitation. There is the temperature of 17.2, dew point of 16.7. So again, that may be getting into the weeds just a little bit, but that gives you the absolute specific. Even though they say it's 1717, it's actually 17.2 and 16.7 temperature and dew point spread there. Okay, so that's how to read a METAR. Now let me go ahead and show you what that looks like on Foreflight. Okay, so I'm on Foreflight here. I'm going to show you where we can look at those METARs. So if you look right here, we're going to go to this airports tab. And then I'm already at Gadsden, but you can hit this little search bar right there and type in whatever airport that you want. So I'm going to hit Kilo Golf Alpha Delta. All right, and then I'm going to go to weather right here, and here's METAR. Remember, there's your TAF, there's your MOS, there's your daily that we were talking about. We'll get into that more so in just a minute. So right here, let's just read this raw data. Why not? Kilo Golf Alpha Delta is the identifier. This is the day of the month, so it's the 24th day of the month. Here's the Zulu time when this was issued. Again, it's one minute weather. However, when you look at it here, this will only be updated every hour. If you can see, that was updated 38 minutes ago. However, the AWOS this is an AWOS. AWOS is 1 minute weather. So if you're checking it on the radio, it is every hour, but Foreflight just only does it once an hour pushing here. But anyways, 24th day of the month at 14:56 Zulu, automated weather observations, wind is 060 at 6 knots. So first 3 is your direction. The next 2 is your velocity. 5 statute miles, BR is baby rain. We're going to look at what all these mean in just a minute. Overcast at 1,000. So again, just add 2 zeros to the end of that. Temperature 12, dew point 12, altimeter 3024, mark AO2. We talked about that. Sea level pressure 245. The temperature is actually 17.0. No, I'm sorry, 11.7. I can't read. And 11.7. So temperature, dew point are exactly the same. So that's maybe the reason why we have bad visibility and mist. All right. And then that little, actually, that's kind of funny. That little dollar sign means that there's maintenance on there. But okay, so yes, you have to read this raw data, okay, for your check ride. However, look what Foreflight does right here. It makes it so easy, right? Wind are 060 at 6, 5 statute miles, overcast 1,000, mist, temperature 12 degrees Celsius, dew point 12 degrees Celsius, and then it breaks it down by Fahrenheit, altimeter 3024, humidity 100%. Well, yeah, because the temperature, dew point are exactly the same. And then here's a really important one. It gives you density altitude. So remember we talked about performance and limitations, part 2 video, how we can use this density altitude for our students to go straight into our performance chart. So with a density altitude 181, we covered all that in the performance and limitations. So this is how to read a METAR. All right. So when we do the terminal air forecast in just a minute, it's going to be very similar. But again, Foreflight does an awesome job. It just breaks it down in plain English, if you will. All right. But again, you do need to be able to read raw data for your check ride. Okay. So let's go back to here and let's talk about the terminal air forecast. All right. So terminal air forecast, again, we've already talked about this. It covers a 5 nautical mile area around the station. It's issued 4 times a day, every 6 hours. Normally covers a period of 24 hours, sometimes 30 hours, but you'll normally always see it covering a period of 24 hours. So what I'm going to do is break this down. Now, again, this is raw data. I'm going to show you Foreflight in just a minute. We'll read the exact Foreflight one here in just a minute, but let's just use this example because everybody has this. If you have it printed off or if you have it in front of you, this will makes a little more sense. So I'm going to go each little step right here, and again, don't worry if you do have that printed off. Here's your legends. It's on the next one. We'll talk about that in just a second, so you can follow along with me with the legend. But okay, let me kind of zoom in here just a little bit. All right, so it looks kind of similar to that METAR, right? And most people look at this and go, holy smokes. I want to break it down and make it a little simple, all right? So first, you start off with the station. So this is a terminal air forecast. This is at Birmingham, all right? This is when it was issued. This is the exact time of when it was issued. So the 23rd day of the month, those first 2 is always going to be what day of the month, and it was at 23:30 Zulu. Remember how to convert Zulu time. Right now it's standard time, so for Alabama, it's military plus 6, all right? This is the valid time. So this is when this TAF is valid, all right? So it was issued at 23:30 Zulu, but it's saying it's valid from the 24th day of the month at 00 Zulu to the 24th day of the month at 2400 Zulu. So you see, this is a 24-hour period, okay? Now, the way I want you to work through this problem is the weather, this weather right here, we're going to break that down, but this weather starts at 00 Zulu on the 24th day of the month. And then what I want you to do is I want you to go until there's another FM, which is from, okay? So from the 24th day of the month at 0000 Zulu until, don't go by any tempo right here, we'll talk about it in just a second, but go to the next from. So from the 24th day of the month at 0000 Zulu to the 24th day month at 0200 Zulu. So for 2 hours, this is your weather. So variable at 4 knots, P is greater than, you're not going to see that on a METAR, but P is greater than 6 statute miles, vicinity showers. Again, look at that legend. If you're following along with me, just look at that legend and it will make sense, okay? Broken, remember add 2 zeros, so broken at 800, all right? So for 2 hours, from the 24th day of the month at 0000 Zulu, go to the next from, 24th at 0200. So for 2 hours, the weather's going to be that. All right. Now, what it's giving you right here is temporarily. So it's saying temporarily between the 24th day of the month at 0000 Zulu and the 24th day of the month at 0200 Zulu, it's going to be broken at 1200. Remember, add 2 zeros to that. So broken at 1200. So for the most part, the weather is going to be this until here, but they're saying temporarily it could bump up to 1200 broken instead of 800 broken. Okay, now we're going to do the exact same thing. We're going to go from to from. We're going to skip everything. We're going to go from to from. So from the 24th day of the month at 0200 Zulu until the 24th day of the month at 1100 Zulu. Okay, so for 9 hours now, 0200 Zulu in the 24th to 1100 Zulu in the 24th, this is your weather. So it's going to be variable at 3 knots, 5 statute miles, baby rain, which is mist, overcast at 800. All right. Now, right here in between, they're saying, hey, there's a 30% probability. So Prog 30 means a 30% probability from the 24th day of the month at 0900 Zulu to the 24th day at 1100 Zulu. So for that 2 hour span, 30% probability of this weather, which is 2 statute miles, visibility, thunderstorm, rain, mist, and then overcast, add 2 zeros, so that's 100, overcast 100, CB is cumulonimbus. Again, we're going to talk, you got the legend on the next slide, all right? We're going to keep rocking right down here. So we're going to go from to from, skip everything in between until you're done with the from to from. So from the 24th at 1100 Zulu until the 24th at 1400 Zulu, the weather is this. All right, so that's a 3 hour span, right? So for 3 hours between 1100 and 1400 Zulu on the 24th, variable at 4 knots, 1 statute miles, baby rain, mist, overcast 300. And here's another 30% probability, okay? Prog 30, 30% probability between the 1100 Zulu on the 24th to 1400 Zulu on the 24th. So that 3 hour period, half statute miles, thunderstorm, rain, fog, overcast, add 2 zeros, 100, cumulonimbus. All right, and you're looking at this and like, holy smokes, just think bad computers back in the day for this. All right, now from to from, all right, from the 24th day of the month at 1400 Zulu till the 24th day at 1800 Zulu, here's your weather. Winds 170 at 6 knots, 6 statute miles, mist, overcast 800. Okay. From the 24th day of the month at 1800 Zulu till the 24th day at 2200 Zulu, here is your, looks like a fronts came through. Here is your weather. 200 at 10, gust to 22 knots, greater than 6 statute miles, broken 2,900 feet. All right. Next, from the 24th of the month at 2200 Zulu until, where's my next FM? Where's my next FM? We go up here to the end of the time. Okay. So from the 24th day of the month at 2200 till, oh, there's not another FM. So here's your next from. Okay. So from the 24th day of the month at 2200 Zulu to the 24th day of the month at 2400 Zulu for that 2 hour span, there's your weather. 200 at 11, greater than 6 statute miles. Rain showers, so that's moderate because there's not a plus or a minus, so moderate rain showers, broken at 7,000 feet. And then there's a 30% probability between the 2300 Zulu on the 24th and 2400 Zulu on the 24th, 4 statute miles, thunderstorm, rain, overcast, 2,500, and cumulonimbus. Okay, that's a fun one, isn't it? That's a good one to practice on. Now, let's go back to the iPad and let's do a real one right now, just for a little bit of extra practice. You guys need to be able to do this raw data. So I'm just going to go right here. I'm on Foreflight. There is your terminal error forecast, and boom. Oh, this is a good one too. Man, this is awesome. Okay, so this is when it was issued, 24th day of the month at 11:44Z. The valid time is the 24th day of the month at 12Z to the 25th day of the month at 12Z. So there's your 24-hour period. So from, I'm going to just do this fast, from 12Z on the 24th until 14Z on the 24th, there's your weather. All right, winds 120 at 9, greater than 6 statute miles, vicinity showers, overcast 2,700. Oh, here's some wind shear. That looks fun. WS at 020. That's wind shear at 2,000 feet. Winds are 160 at 35 knots. Whew, that's a fun. I don't think that may be a no-go decision on a 172, right? Okay, from 1400 Zulu on the 24th to 1500 Zulu on the 24th. So only 1 hour. Winds are 130 at 10, greater than 6 statute miles. Vicinity shower, overcast at 1200. From 1500 Zulu on the 24th until 2100 Zulu on the 24th, here's your weather. Winds 140 at 10, greater than 6 statute miles, vicinity showers, broken at 500 feet. Now, you see how this is blue and red? Okay, Foreflight just tells you, okay, that's marginal VFR, that's IFR, and then if it's green, it's VFR. Okay, so they just color code those. So just don't get confused with that. All right, so from 2100 Zulu on the 24th until, go to the next from, 0300 Zulu on the 25th. Okay, so 2100 Zulu on the 24th, the 0300 Zulu on the 25th. There's your weather. 150 at 10, 5 statute miles, rain showers, baby rain mist, overcast, 1,000 feet there. Okay, just add 2 zeros. Now, 30% probability between the 2100 Zulu on the 24th and 0300 Zulu on the 25th. Thunderstorms, rain, mist, overcast, 800 cumulonimbus. And then from 0300 on the 25th to, there's no other from. Where's my other from? Go back right here. So it's the end of the valid TAF. So from 0300 Zulu on the 25th to 1200 Zulu on the 25th, there's your weather. 170 at 8, 3 statute miles, rain showers, mist, overcast, 500. 30% probability between 0300 Zulu on the 25th and 06 Zulu on the 25th. 2 statute miles, thunderstorms, rain, mist, overcast, 500 cumulonimbus. Okay, so that's a fun one, right? That's a fun one. Now, so one thing I did want to add is, if you see right here, it says not SCED. So I kind of wanted to show you what that means. But beforehand, this forecast discussion, that's actually a pretty good little deal there. If you pull up this basically, remember, I told you that meteorologists come up with this, right? So if you go to the aviation discussion, this kind of just shows you in detail. Again, it kind of gets in the weeds a little bit, but it kind of shows you in detail what they're thinking of. And right here, note, there's that not SCED at Talladega. ASN is Talladega, due to a comms issue. So they're telling you why it says that. But I did want to show you kind of what that means. So the abbreviation not SCED and a TAF indicates that the forecast is unscheduled. This means that the TAF was issued outside the regularly scheduled issuance time. So we talked about when it's normally scheduled, every 6 hours, 4 times a day. Right there, which are typically every 6 hours. So the not SCED remark is added to the end of the TAF along with the time of the last observation and when they are to resume. So, it says, although observations might not be available, the TAF is still valid to the end of the scheduled valid time. So that doesn't really matter. Again, that's kind of getting into the weeds a little bit, but I did want to show you what that means there. All right, everyone, just one thing I wanted to add here on the terminal area forecast. So like when you see right here, where you see, we went through all of this, right? But where it says vicinity shower. So what that means, when it's saying vicinity, remember that this forecast is only good for a 5 nautical mile area. So what it means by vicinity is that it's not necessarily saying at that terminal area location that there will be showers, but just outside of that 5 nautical mile ring, which means the vicinity, that there could be showers. And anytime you see, like right here, like thunderstorm and rain, it doesn't say vicinity. So they're saying, hey, within that 5 nautical mile circle, we could have thunderstorm and rain. So I just wanted to point that out. Vicinity shower. So when you're seeing vicinity on a terminal area forecast, that just means that they're saying it's going to be outside that 5 nautical mile ring. Okay, so just wanted to point that out really quick, and also wanted to say, let's just go through a little scenario where I'm going to use those 4 things, that we've talked about as far as the TAF, the GAF, the MOS, and the daily forecast to do a look at the weather. So we're just going to simulate. Let's just say that this is the night before, and we're going to do a flight at 1500 Z for the next day. Okay, so that would be 9 o'clock in the morning during standard time. So we're going to do a flight tomorrow at 9 o'clock. So what do we expect the weather? So I'm going to go through those 4 things, just kind of show you really quick how I want you guys to look at that that weather, that W of the NWKRAFT. So we're going to go to Foreflight here, and we're going to start off with the terminal area forecast. So we're going to be, again, looking at tomorrow at 1500 Z. So again, convert that. 9 o'clock in the morning is 1500 Z. So let's look right here. I'm going to pull my iPad. So it looks like we've got from 0400 Z until 20 Z on the 25th. So this is going to be our weather right here. All right, so between 0400 Zulu and 2000 Zulu, so we're looking for 1500 Zulu, so it's going to be inside that weather. So tomorrow at 1500 Z, the TAF says 150 at 8, 4 statute miles, rain showers, mist, and overcast 700, and then 30% probability between 0900 and 15 Z. So this would be us. It'd be kind of on the end of it, but 1 statute miles, thunderstorm, rain, mist, and that looks like overcast 200 with cumulonimbus. So not really good, right? So basically the winds out of the southeast, rain showers, mist, overcast 700, okay? So that's what the TAF says. Now, since we're right here, let's just look at the MOS for tomorrow at 9 a.m. So it looks like right here from 8 a.m. until 2 p.m. It's looking like winds are 180. So it's saying instead of 150 winds, it's at 180 at 9, gust of 14 knots, 2 statute miles. So it went from 4 on the TAF to 2 here, broken 300. And rain. So that's all about the same. So it's showing, a little bit less because that's basically showing 700, but it does give us a possibility, 30% probability it goes down to 200, but the MOS is showing about 200 there between 8 and 2. So that's the weather that the MOS is showing. Let's go to the daily. So right here on Thursday, let's go to 9 a.m. and it's showing basically the same thing as MOS, which is not really surprising because they're both model data, right? The low FR, 200-foot ceilings, winds 162 at 5. So the TAF was 150 at around 8, I think it was. The MOS was about 180. This is about 160. So you can kind of get a general feeling. It's out of the southeast to the south, about 5 to 10 knots. And then last thing, we're going to go here to the GAF. So we're going to go to imagery. And then we're going to go over here to the southeast surface. And I'm just going to pick one. I don't know which one this is it. So that's valid at 09. That's valid at 12. That's valid at 15. So this is exactly what we're looking for. So you can see here, okay, thunderstorms, really bad visibility. Remember we talked about this is, let's look at that. Right here, so that's 0 to 1, 1 to 3 is the pink, 3 to 5 is the blue. So it looks like some pretty bad visibility there. So it's looking like what was that? I already forgot what the code is. So it's looking like 1 to 3 miles visibility with pockets of 0 to 1 mile visibility. So that's about right on with the TAF and the MOS thunderstorms. This is showing the wind barbs basically. So where Gadsden is about right here. Okay, that TAF was located about right here. But this is showing, this is kind of lining up with that MOS, it looks like. So winds due out of the south at 15 gusts to 20. All right. And so, yeah, it looks like basically winds are out of the south. That's the worst one that it showed. I think the MOS showed gust about 14. So this one's showing 15 gusts to 20. And then let's look at the cloud height. So southeast cloud. And I believe that was, well, we're going to go to one more. There's our 1500Z. And that's showing overcast 800. So that's kind of what I'm doing. So you can kind of determine that the weather is somewhere in between, 700 foot overcast. The GAF was showing 800 foot overcast. MOS was showing like 200. Model data was showing 200. So it's going to be somewhere in between that, right? The winds more or less out of the south to southeast at anywhere from, this is showing, 8. Some were showing 15 to 20. So I just wanted to kind of show that really quick. This is how that I think is the best way to kind of determine for a flight that W, that 91-103 pre-flight action, that W, to determine what the weather is going to be. So just using those 4 resources, wanted to show you there. And last, I will say too, so anytime you are reading this, so I'm going to kind of talk what true versus magnetic. Okay, so what I mean by true versus magnetic is when you kind of get this into cross-country flight training. But if you see here on this chart, this little line right here, so this is an isogonic line. Okay, so this is the difference between true heading and magnetic heading. Again, this is getting into post-solo. For all your pre-solo students, you're not going to understand what this is, but this is the difference between true north and magnetic north. So what do I mean by that? This is your magnetic. So that is pointing to the pole, right? The magnetic north. True north is literally just straight up and down. All right. So 4 degrees is the difference between true north and magnetic north. Again, you're going to get into this in the cross country stage, but west is best, east is least. So you would add 4 degrees to go from true to magnetic. But the reason why I say that is because I want you to understand that when you read the weather, when you read it, it's true. When you hear it, it's not. So think about gossip and stuff like that, right? So when you read it, so when we're reading this winds 200 at 3, that is true heading. Okay, so that is not magnetic. You would technically have to do that 4 degrees conversion. So west is best. You would add 4 degrees. So that would technically be the winds were a magnetic 204 at 3. Now, when we go here to taxiways, when we see our runways, all right, this is jet chart, so if it looks a little different from the Foreflight chart, but when you see these runways, these are magnetic headings, right? And these are true. So here in Gadsden, it's not that big of a deal, right? But let's just say we go over to, a place like Anchorage, Alaska, and there's a isogonic line. See, there it is right there. So that's 16 degrees. Well, that's a little bit more of a difference, right? East is least, so you'd actually subtract 16 degrees to go from true to magnetic. But we go to the winds aloft over here. These winds aloft are in true. Okay, so everything that we're reading here, true, daily, MOS, TAF, METARs, when it pertains to the wind direction, that is true. Okay, now if we hear it, so if we are going to, call the AWOS, so here's the AWOS, there's the number. So if you picked up the phone and called, and you're hearing it, it's magnetic. If you are listening to it on the radio, it's magnetic. Okay, so to kind of show you that difference between reading it and magnetic, let's go over here to Anchorage. And Just going to pull up that airport. There it is. Details. So let's go to weather. Okay, so right here, you see winds are 140 at 3. All right, but that's true. So there's a 16 degrees east. So you would have to subtract 16 degrees right here. So the actual magnetic winds would be about 120. All right. Now I'm going to pull up this ATIS. Now this is technically reading it, but this is the ATIS that you would hear on the ground. They're just giving us in form. So you see right here, winds are 120 at 3. Well, why is it different? It's because this is magnetic. So the ATIS, this would be the only caveat where you would read it, would be this digital ATIS. You're only going to get this with the performance stuff, the performance subscription on the iPad with Foreflight. This would be, so like if you called the AWOS, or it looks like they have an ASOS. So if you called that ASOS right there, you would hear 120 at 3. However, when you're reading it, because that 120 at 3 is magnetic, but when you're reading it, it's 140 at 3 because this is true. Okay, so just remember, when you read it, it's true. When you hear it, it's not. So gossip is not true. So it's magnetic core. So this is an extreme example, but it kind of gets the point here. So this is true. If we went to the TAF, went to the MOS, the daily, the winds aloft, everything that we're reading right here is in true. Okay, so but if we again picked up that phone and then we called that ASOS right there and listened to it, then, or the digital ATIS, if we called the digital ATIS, it would give us magnetic, and it would be just like that. Okay, so this is the only time the digital ATIS, that 1203 is magnetic. Okay, so it's an extreme example here around in Alabama, a 4-degree west. So you would add 4 to go from true to magnetic. That's not a big deal. I mean, you know, so you're pretty much going to always see them align. But repeat it after me. Remember, if you read it, it's true. If you hear it, it's magnetic. Okay. All right. There is our legend. All right. So pretty self-explanatory here. The minus sign means it's light. If there's no sign, it's moderate. Plus is heavy, and VC is vicinity. Here's some of your stuff here: thunderstorm, freezing, partial, shallow, blah blah blah, drizzle, rain, snow. You know, you can just read all through that. Fog, baby rain, smoke. I think that's from Fuma, F-U, and so forth. So you can just read it there. Okay, so this is going to be your sky cover chart. So these symbols are going to be, we're going to see this on the graphical aviation forecast here in just a minute. But these are basically your sky cover legend, if you will. So if you can see here, you know, solid would mean overcast. These 3 symbols would mean broken. It's dependent upon what sky coverage. So that'd be, you know, 5/8, 6/8, 7/8 coverage. 8 out of 8/8 coverage would be overcast. So from 5/8 to 7/8 would be broken coverage. That's what's spelled down here as well. And then 8 out of 8 would be overcast. Let's see, 3/8 to 4/8 coverage would be scattered, so that'd be indicated here. And then 1/8 to 2/8 coverage would be outlined by this, and then completely clear would look like this. So again, you're going to see this on the graphical aviation forecast. A ceiling is defined as broken or overcast. Okay, so scattered, few, or clear is not a ceiling. Broken and overcast is defined as an actual ceiling there. Okay, so here's kind of defined. If it's 1/8 to 2/8 sky coverage, it's few. If it's 3/8 to 4/8, it's scattered. If it's 5/8 to 7/8, it's broken. If it's 8 out of 8 or overcast, it is overcast. So again, broken and overcast is a ceiling. Okay. Now, what if we don't have access, Now, what if we don't have terminal air forecasts within 5 nautical miles of the area? What are we using? Okay, this is what we're using. It's the graphical aviation forecast. It's formerly called the area forecast. Can be found on the Foreflight under the imagery and through the briefing. Also can be found on aviationweather.gov. It basically covers a large area of several states. Is used for forecast of weather where a TAF is not published and available. There's the aviationweather.gov, but of course I like Foreflight, so I'm just going to show you where that is on Foreflight. Okay, so if you go right here, you see this little imagery button. Again, if you're doing a Foreflight briefing, I do that briefing in the Foreflight flight planning and briefings video, so you can check that out. But here is where we're going to go to get the graphical aviation forecast. That's right here on imagery. CONUS would be the whole entire U.S. We're just going to go to the southeast, and we're going to pick one of these. Now, I have no idea what time is valid, but I'm just going to hit the 6 hour. And then I'm going to zoom in, and it'll tell us when it's valid. So you can see right there, this is valid at 1800 Zulu on Wednesday the 24th, all right? So you can see this covers a large area, right? So there is your sky coverage. So that's that. I'll show you again that legend, but that means it's overcast, all right? This would mean it's few. All right, so that's kind of telling you that sky coverage that we looked at in just a second, or just a minute ago. So this is basically saying, hey, overcast 1300 tops at flight level 320. So above 18,000 feet, it goes to flight level. So that's 32,000 feet, and it says cirrus above. Okay, and then also these things have great legends, right? So down here at the bottom is your legend. So it shows you the color code, if it's fused, scattered, broken, or whatever. Airments, we're going to get into airments and segments. That's in part 2, though. So weather information part 2 is where we get into the airments and segments. Okay, but you can kind of see this is a forecast for a large area. I mean, you can kind of quickly look and see, okay, weather's not so great up here, right? Overcast 1300, overcast 1500, overcast 1200, tops are at 28,000. So you're in the clouds a while, right? But then you come down here to, Florida area, weather looks pretty good, right? A few clouds at 3,000 or so forth. So this is the cloud portion of, in the TAF, it's giving you winds and cloud height. So for this is the cloud height portion of it. I'm going to go back, I'm going to hit close there. And next is I'm going to hit the southeast surface. All right, I'm going to go to that same 6 hour one. And again, I can just kind of zoom in on 1800 Z. So this is valid at 1800 Z. Of course, you can just scroll. So there's 2100 Z, and then keep scrolling if, for whatever valid time that you're looking at. But yeah, this looks like some pretty terrible weather right here, right? So lots and lots of symbols on here. I'll show you the chart that breaks all those down. Basically, this means thunderstorm. All right, here's your wind barbs. I'll find something that's not so. Well, yeah, here we go. Let's go down here to South Florida, or Central Florida. There's your wind bars. So this is where the direction of the wind is going. Okay, so this is coming from the southeast, and this is 10 knots. That's 5. The red is a gust. So this is 10 gust to 15 coming from the southeast. So, look at your airport diagram. You're going to be landing into the wind, right? So you'd be landing to the southeast. These little guys mean rain showers. All right. You can kind of see those are all over the place. That's just rain. And again, this is thunderstorms, and there's your wind barbs in the middle. Boy, that's some pretty gusty winds. So looks like it's 15 sustained, gust to 25, because that's 10, 20, and then 5, and the red is gusts. So sustained winds is 15. So the 10 and 5, gust to 25. That looks like some good weather. Go down here to your legend. Down there. So this kind of shows you what everything is looking like, in the color codes: rain, snow, mix, ice, smoke, fog, haze, dust, sand. So IFR conditions. Here is, so if you saw those thunderstorms, That right there, see how it's dark, like a magenta dark? That's right here. That means they're numerous, 60 to 100%. So everything has legends, guys. So just go straight to that legend, and it will kind of break down what all that means. And again, visibility. So you see all these pink colors and all that. That just has to do with visibility. See down here? If it's purple, it's 0 to 1 mile. So all this is less than a mile visibility. That's pretty bad weather. 2 to 3. All right. So 2 to 3. And then 3 to 5. That's all your marginal VFR stuff. And then if it's just white, like you see down here, then that would mean it's greater than 5 miles of visibility. Okay. So graphical air forecast, pretty good, right? There's your winds. There's kind of, thunderstorms and rain showers and all of that good stuff. All right. So that is your graphical aviation forecast on Foreflight. Let's go back to here, and then yeah, guess what? We've got your legends for you. All right. There's all your symbols. So when you're looking at that graphical aviation forecast and it's like, what does all that stuff mean? We saw the thunderstorms. We saw the showers, the rain showers. We saw the rain. Remember those dots? Okay, and all that good stuff. There's your wind barbs. The triangle would be 50 knots. I broke that down. That's 10. That's 5. And again, it's pointing the direction. So this one, the winds are out of the west. All right. So winds are basically looks like 270 right here. So it's pointing in the direction that the wind is going. And then we're going to talk fronts all in just a little bit, but this high pressure, low pressure, all that good stuff. So always use this legend. So I hope that helps. That broke down the METARs, the 3 types of METARs: ATIS, ASOS, AWOS. ATIS and ASOS are 1 hour weather. ASOS is controlled by the National Weather Service. That's the bee's knees, right? The ASOS is the best. AWOS is FAA controlled. It's only for us pilots. It's just, and it's all over the board. But it's a 1 minute weather. It's the AWOS. Okay. Terminal air forecast, 5 nautical miles. We broke that down, how to read it, be able to read it raw data. But Foreflight gives it to you nice and easy. And then if you were using that graphical aviation forecast, if we don't have a TAF in the area. Now, again, the other two was the model output statistics. So again, when I'm looking at weather, I'm looking at we'll go back here to the airport. All right, METARs right now, we looked at that. But like forecast wise, I'm looking at the TAF. Now, again, this is Anniston, and it tells me it's 24 miles away. So technically, I can't use that for Gadsden, but I can use it as a ballpark, right? So I'm looking at the TAF, so like if I was going, this afternoon, so from 9 a.m. to 3 p.m., winds are 140 at 10, 6 statute miles, broken 500 feet, showers in vicinity. And then I would go to the MOS. And again, this is just model data. All right. So no meteorologist is building this, but you can see it looks fairly similar, right? Broken 700, so forth. Then I could go to the daily, same thing. Click on Wednesday. This is telling you ceilings and percentage of rain and winds and visibility and all that. Again, model data, so take this with a grain of salt. All right. But that's kind of what I'm looking at is the MOS, the daily forecast, the terminal air forecast, and then again, this graphical aviation forecast, and the weather's going to be somewhere in the middle of it is kind of what I think. All right, let's go back here and continue on. Okay, so this is where we're going to get into atmosphere stability. We're going to get into fronts and all of that fun stuff that you need to know for your check ride. And of course, what you just need to know practically, in flying. Okay, so the way I want to break this down is just this number 1, and we're going to be finished with this first video. So what's the greatest hazard, I think, in this summertime is thunderstorms. Okay, so what makes a thunderstorm? So there are 3 things that make a thunderstorm. We have a lifting force. All right, so what can give us a lifting force? That's where we're going to talk about cold fronts and all the different types of fronts and how that could possibly give us this ingredient of the thunderstorm, which is lifting force. Also, during the summertime, daytime heating, heat rises, right? So that can be a lifting force. But not only do you need lifting force, you need instability. All right, so this is where we're going to talk about atmospheric stability, talk about high pressure and low pressure. All right, and then last is moisture. All right, so again, in performance and limitations videos, we talked about how moisture is a factor in performance, and the fact that moisture here, it's air filled with water, so high humidity is actually lighter and will rise above the drier air because it's hydrogen, 2 parts hydrogen, 1 part oxygen. All right, it will tend to rise if allowed. So moisture actually helps with the lifting force here. And if you have instability along with that moisture, all right, that's lighter, thinner air, the moisture will tend to rise. So let's break each one of these down. All right, what can give us lift, what can give us instability, and then moisture is moisture, right? Down here in Alabama, usually the Gulf of Mexico gives us a majority of our moisture. All right, so stability. You need instability to create a thunderstorm. So here is atmospheric stability. It's pretty easy, okay? So we have high pressure and we have low pressure. Now what high pressure does is it has sinking air, all right? So let me show you this graphic here. Do you see this high pressure has sinking air? So there's stability right there. There's not instability, all right? If we had a lift force, if we had moisture and a lift force trying to lift those particles up, that sinking air is like, nope, you're going back down. All right, so even if you had lift and moisture here, you wouldn't create thunderstorms or bad weather because you have this sinking air. You see this nice pretty cloud up here. Also, if you look, the winds along a high pressure go clockwise. All right, so that may be a question you would get on a check ride or something as well. All right, high pressure winds go clockwise around high pressure, and again, it is sinking air. So what does that sinking air give us? Good flying weather. Okay, rotates clockwise. It tends to hold down any upward development, right? Prevents the instability. So without an uplift force, we can't get moisture rising, which is the fuel for most of the weather. Cold air sinking. Cold air is more dense and wants to keep sinking. All right. So that's what high pressure is. High pressure is good flying weather. We like that. Now, conversely, low pressure. Let's talk about low pressure. So low pressure is usually bad flying weather, okay? Let's look at this little graphic here. You can see how low pressure doesn't prevent that lift. It's rising air, okay? So it's not sinking air, it's actually rising air. So if you get any sort of lift, it's just going to keep letting those particles of that moisture rise up, creating this clouds and instability, okay? So stability is basically like if you get a molecule going, so this is stable. So if you got a molecule rising, it's going to tend to return back to its state, right? That's stability. But instability means you get a molecule displaced and rising. It's going to continue to become displaced and displaced and displaced. So it doesn't have any stability. So that's what low pressure is. You see here, there's your counter. Look, think of a hurricane, right? How does a hurricane up here in the northern hemisphere has a hurricane go, right? Counterclockwise. So that's how low pressure winds do counterclockwise there. There's a indication again of clockwise rotation around high pressure, low pressure, counterclockwise rotation. And if you look at these bars right here, all right, we're going to look at this on a surface analysis chart, but these are called ISO bars. So ISO meaning equal bar pressure, okay? So lines of equal pressure. So the tighter these things get, the more wind you have. So what is, basically wind is, it's a combination of pretty much like Bernoulli's principle, right? Like how do we make lift on a wing is we speed the air up over the top of the wing more than the bottom of the wing, right? So that the increase of airflow over the top creates a low pressure, and then you have high pressure on the bottom of the wing. So high pressure and low pressure are always trying to mix. So that's what are trying to equalize. So that's why you get the lift. That's how winds are, throughout the planet, is basically just winds trying the high pressure, low pressure trying to equalize. So if you see isobars that are close together, where you have pressure differences close together, then that's going to mean more and more wind because the pressure difference is higher. So think about the more pressure difference you get between low pressure and high pressure on your wing, as far as how fast that the airflow is, the more lift you'll get, because it's more difference between high pressure and low pressure. Same thing here, is you would just get more wind. Okay, so pretty easy as far as atmospheric stability. I just want you to know high pressure is good flying weather, low pressure is bad flying weather, sinking air, and clockwise rotation. This can create instability, rising air with counterclockwise rotation. All right, let's talk about some of these fronts. Okay, so this is a warm front, and this is showing the direction of movement too. All right, so this is the warm front, so that means you got warm air on this side, you got the colder air on this side. Warm front is warm air replacing cold air. We're going to dig in deep on all of these, but cold front, direction of movement here. All right, your cold air is there, your warmer air is there. Your cold front is simply cold air replacing warm air. All right, here is an occluded front. All right, this would be the direction of movement. We're going to talk about an occluded front, but occluded front is basically when a cold front catches up with a warm front and then catches up with the colder air in front of the warm front. We'll talk about that in just a second. And then stationary front right here. Direction of movement is that way, but remember, a stationary front is going to be where cold front and a warm front meet, and they're not powerful enough to move each other. So let's break each one of those down. So this is where we can get our lift, right? So cold front right here, unstable lifting force, forces warm air aloft. Whoop, whoop, there it is. Storm squall lines, wind shear. All right, what is wind shear? You're going to talk wind shear avoidance as a special emphasis item. These cold fronts can create wind shear. Wind shear is simply a change in direction and velocity of the wind. All right. Why wind shear is bad is because if you had a 20, 10, 15 knot headwind and then it shifts 90 degrees, well, you just lost 10 or 15 knots of airspeed, right? So the FAA tells us to add half the gust factor to our approach speeds up to 10 knots to counteract for that wind shear. Okay, so just basically, how do you counteract for wind shear? On takeoff, you increase your rotation speed, so just delay your rotation a little bit, build up a little more energy, and then pop the airplane off the ground. Conversely, on landing, just fly at a faster airspeed, keep that energy state up for wind shear. Okay, but most airplanes up to 10 knots. You don't really want to go faster than 10 knots of your landing speed. Okay, unless you had like tons of runway, but stabilized approaches. Anyways, I digress. So cold front is cold air. So you can see this cold air replacing the warm air. All right, this is the direction of the movement. So you can see how this gives us lift, right? Which cold air is more dense than warm, right? So it's like a bulldozer. If you look at it right here, it's like a bulldozer that's forcing that air upwards. Okay, so we can get cumulonimbus clouds and so forth, right? So lifting a warm, moist air out of a cold front. So this can give us that lifting force when of what creates a thunderstorm, right? So big stuff there as far as what a cold front does. Again, think about it like a bulldozer. Think about this as a bulldozer that's forcing that warm air aloft. Okay, which if you combine that with instability, you can get and moisture, you're going to get thunderstorms, right? But instability could equal good visibility. The way I like for students to remember this is think about like a pool, right? If you shut all of the pool pumps off and you have perfectly calm water, what's going to happen over time is you're going to see all those particles and it's going to get cloudy, right? If you've got that pool pump running and you've got this turbulent, unstable, water, if you will, fluid, same thing with air. If you mix all that up, you could get that good visibility. Okay, so you don't have those stagnant particles. But this is what a cold front does. It can create lifting by lifting that warm air up. Okay. Now, conversely, let's look at a warm front. So a cold front is cold air replacing warm air. bulldozer, boom, forces that warm air upward because heat rises anyways. And then a warm front, what it's doing is it is warm air. So you see this warm air, that's replacing cold air. But what's more dense, right? The cold air is more dense. So you get this layering effect right here. So you kind of get this warm air. It still rises, so there is still a gentle lifting force because this warm air is going to kind of rise over this cold air. Remember, cold air is more dense than warm, all right? So you're going to get this cloud development, but it's not going to be like cumulonimbus type clouds where, you know, that like cold front just boom forces that, but that warm air aloft. This one is more of a gentle rising. So you're going to get more like stratiform clouds, steady precipitation, and so forth. So you're going to have stable air, kind of resists lift, right? Because you see how, you know, you don't get this crazy lifting. Again, you do get a gentle lift as that warm air is overtaking that colder air, and that's why you see this cloud development here. But could equal poor visibility because there's not all of that mixing up, but it's probably going to be smoother because it's stabler. Freezing rain possible too, because you know, one of our first live videos we talked about icing and weather information and all that stuff, and we were having freezing rain that evening, and I showed why that was the case. All right, so you can get that with warm fronts, so basically a temperature inversion. So what's happening to the temperature of the air as you go up in altitude? It's actually getting warmer, right? So you get that with a warm front, you get that temperature inversion. You know, it's not 2 degrees Celsius per 1,000 feet, all right, in this standpoint. So that's what a warm front does, is it's just simply advancing warm air um, that's overtaken this cooler air, so you get this kind of gentle lifting, stratiform, steady precipitation type stuff. Obviously, with this like cold front here, boy, there's your thunderstorms because you get rapid development into like cumulonimbus stuff. Now, what's an occluded front? All right, so an occluded front is basically a cold front that overtakes a warm front and then catches up with the colder air on the other side. So if you look right here, this is going to be a combination of weather of a cold front and a warm front, all right? So it's not all that hard to understand. Here is your cold front right here, all right? Your cold front stops right there. There's your bulldoze effect, all right? Remember, that cold front is replacing, you're replacing that warm air with cold air, and so the cold air is more dense, so it forces this warm air up. Here's your cumulonimbus clouds, right? There's all your lifting force because this is the cold front right here. There it is there in this picture, okay? This is your cold front. And then it's overtaking the warm front. That's what this occluded front means. Here's your warm front. It starts right here. You see how this gentle lifting? Remember we looked at that with the warm front? There's your gentle lift of a warm front. Remember, a warm front is overtaking this cooler air. So this warm air will tend to rise over that cooler air. That's the reason why you get this nimbostratus here, altostratus. You get more of the stratiform clouds. See, there's not as much development. We're going to talk cloud heights or cloud stuff in just a minute. But there's your warm front, and then here's the colder air on the other side of it, and you've got this more stable, you know, cirrus, drier air because it's all right there. So that's what an occluded front is. All right, so it forms when a cold front overtakes a warm front. This typically happens around a low pressure area in which the warm air is separated or occluded from the cyclone center at the surface. So there's where your occlusion is happening. But remember, I just want you to remember, it's when a cold front catches up with a warm front. All right, so there's your cold front, there's your warm front, and you know, the cold fronts are usually faster than warm fronts, so that's what's happening here in an occluded front. So not great weather, right? You're going to have the weather of the cold front with all your wind shear and cumulonimbus stuff. You're also going to have your weather with a warm front, which is going to be more of your steady precipitation and so forth. Okay, hope that makes a little bit of sense on the occluded front. And then last here is the stationary front. So pretty simple. It forms when a cold front and warm front meet, all right? And they're just not powerful enough to move each other. There's your cold front coming in. There's your warm front coming in the opposite direction, and they meet right there in the middle, and they're not strong enough to move each other, you know, so they can stay for days. All right. Usually the winds are going to blow parallel to the front. All right. Um, but they're basically just fighting it against each other, and neither is powerful enough to move the other. So what kind of weather are you going to get with this? You're going to get, again, a combination of the two. Probably not quite as bad weather as, you know, an occluded front, but you're still going to get some bad weather with a warm front. So I mean, with a stationary front, because it's both the weather of a cold front and a warm front coming together with lots of moisture and unstable lift and all that good stuff. So we get some bad weather there. So there is your stationary front. Now, here's some of the clouds that we're going to talk about, and after this, we are done with this video. So cumulus clouds, you're going to see this in the summertime a whole lot. That usually turn into cumulonimbus. Nimbus meaning rain. All right. There is your rain coming out of that thunderstorm. Here is your nimbostratus. So this is more associated. This is going to be more associated with unstable cold fronts. This is going to be more associated with warm fronts. There's your nimbostratus. Nimbo meaning rain. Oop, there's a rain, right? Stratocumulus cloud. So it's more like flat, puffy clouds, other than what you're getting here in cumulus. Altostratus is just the height up there. Stratus clouds are pretty benign. And then a cloud on the ground, a cloud within 50 feet of the surface, is fog. All right. Now, when do we get these clouds? That's when temperature and dew point meet. All right. So as pilots, when that temperature and dew point are close together on the surface, this is what we're worried about, is fog. That's 100% relative humidity. So clouds form when temperature and dew point come together, all right? And so a cloud 50 feet over the surface is fog, which is exactly what this says right here. So it occurs when the air temperature near the ground reaches its dew point, or when the dew point is raised to the existing temp by added moisture in the air, right? So you get fog, again, whether if it's the air temperature dropping to the dew point that causes it, or if it's the dew point rising up to the temperature. You know, a lot of times that radiation fog in the middle of the night is usually all of that heat that's from the ground that, you know, the sun heats up the ground, right? And then at night, all that heat radiates up. So all that heat escapes into the atmosphere. So that drops the temperature to the dew point. And then what happens when temperature and dew point are the same? Okay, so anytime, you know, fog's going to form, again, anytime that something happens where the temperature drops to the dew point, or if moisture is added and temperature and dew point comes up to the temperature, right? So again, look at temperature dew point spread on the surface observation system. Look out when they are close together. It equals fog. All right. So that is the definition of fog. There, I'm not going to really go all into this. There's that radiation fog I was telling you about. Here's some valley fog, advection fog, upslope fog, sea smoke or steam fog, precipitation fog. You can read all of those, but really, as pilots, we're just wanting to understand, you know, situations that could create, you know, create fog. Basically, again, anything that brings the temperature down to the dew point, or anything that brings the dew point up to the temperature. All right. So all of these aspects does one of the two. All right, guys, even though I said I think the clouds was the last thing on the video, I did forget to add this in right here, and that is the Prog chart. So we talked about the METARs, the TAF, and the GAF, but if we're looking for the weather up to 7 days advance, the FAA gives us this Prog chart. So prognostic equals future. So let me go to Foreflight. Let me show you that chart there. So I'm going to go here to the iPad, bring us back up here. So we are back at imagery on the bottom of your Foreflight. Then if you look right above my head right here, there is our Prog chart. So we're going to go to that. And then if you see, this is the latest surface analysis. So let's just kind of pull that up. And, you know, like on the oral exam, this is what I'm going to pull up and ask. It's like, hey, what is that? What kind of front is that? Well, it's stationary, right? You know, they're button heads. You got warm air on this side trying to go that way. You got cold air on this side trying to go that way. And it's a stationary front, right? What does that L right there mean? All right, well, that's low pressure. How does the winds go around that, right? Goes counterclockwise. So that's some of the questions that I would ask. What's this up here? All right, well, that's a cold front, right? So you got cold air over here, warm air over here. It's going that direction. What is this up here? High pressure, right? So what's going to have the better flying weather? Up here, high pressure, or down here, low pressure? And obviously, high pressure. Clockwise wind rotation, counterclockwise wind rotation, and so forth, okay? So that's surface analysis, and then this is basically, again, just kind of zoom in on the valid time. So I think we did an example earlier about how we would fly at 1500Z Thursday. So this is valid at 1800Z. This is valid at 1200Z. Okay, so we just use this here, valid at 1800Z. You can kind of see here, it's giving you the front. So there is a cold front. There's our low pressure system, right? There's our isogonic lines, ISO meaning isogonic, isobars, isobars. ISO being an equal, bar being pressure, so lines of equal pressure there. And you can just look here. This hatch means there's a chance of thunderstorms, so there's your chance of thunderstorms. There's your rain is likely because it's all dark right there, and so forth. So you can kind of see this is in this Prog chart, just gives you a general indication of the flying weather. Okay, so you know, these Prog charts go out several days in advance. Like right here would be day 7, but it doesn't really give you precipitation anymore. So by day 7, you know, just gives you a surface analysis chart. So that doesn't tell you a whole lot, does it? I wanted to show you that Prog chart. Now, to me, I'm using pivotalweather.com to get this instead of these Prog charts. So, you know, again, go to that pivotalweather.com, but, you know, I will go ahead and just pull that up. All right, so I'm on pivotalweather.com. I've got this NAM CONUS. We're going to go here to the southeast. We're going to go forecast loop. I'm pushing this right above my head to make sure we are on the latest, and we are. And then basically we're looking for 15Z tomorrow. So I'm up here, and I'm just sliding this over that direction until I get to 15Z. So there's 9, there's 10, there's 15Z right there. So you see, to me, that looks a whole lot better than the Prog chart that we just looked at, right? You know, there's the weather tomorrow at 15Z. You know, doesn't look all that great, does it? You got this line of weather coming in, and it's going to just keep going, and that's not good. So again, it's a little bit getting in the weeds. Watch the video if you want to learn how to do it. I can zoom in here, and I'm basically just going to push right where Gadsden Airport is. I'm just going to tap it. That's going to bring up something called a skew T. I'm not going to get in depth with this because that's what I go in the video. Temperature and dew point are together. So there's where your clouds are. Clouds are starting pretty much at the ground, and winds are going to be basically due out of the south at about 10, it looks like. So that's using all available resources to get the same, basically, information. All this weather information comes right off the ACS for your check ride. So hope it helps. Like, comment, subscribe. Let me know if you have any questions on this or anything I can do better. Appreciate it. Thank you.